So, hey everyone, welcome to the first meet in the beginner track. Today this meet is on C++ and STL, and the point of the meet is to provide a kind of like show of C++, its features as opposed to C, and allow for a smooth transition of C to C++. So, obviously the first question is how C++, right? Yes, I'm guessing everyone is taking C program. And one of the big reasons for using C++ is because it's really fast. So C is one of those low-level languages which is already fast in doing that. But it's kind of clunky to code. There's weird things like memory allocation with malloc. There's pointers which are kind of arbitrary. So C++ is fast. It has features that avoid being clunky.
हाँ क्योंकि पंकज सर आई थिंक आई टू स्टैंड सो अबे चुप करो
guys, can you please calm down because it's also getting streamed and your voices are getting picked up. So if you could be a little quieter, it would be helpful for the people attending.
माइक पे
Okay, so C++ is fast, as I mentioned. It's also not annoying to code in, and it has some really good features that make coding in C++ really fun. Another thing is all valid C code, almost all valid C code is also valid C++ code. So C++ is a superset of C, which means that if you know C, which you guys have taken C code, it's really easy to pick up. And most competitive programmers use C++. And another good thing about C++ is it's almost definitely already set up for you. So for those using Linux, it's probably already set up. And Mac also, it comes with Clang++. For Windows users, we sent a message on the WhatsApp group on how to set it up, and I'm going to assume you guys have set up MinGW and VS Code and stuff. So I'll just show off some basic code for C++ to just show, kind of get you guys familiar with how it is. Here you can see the first line is an include statement, a lot like C. The header you're including is called IOStream, and notice there's no .h. Then there's this something called using namespace std. I won't be going into details of what this is, but for now let's just say it's some boilerplate code you have to add. And then you have your familiar int main, which is the main function which should be called. Just one second. Then we can see this is a hello world program, and we just print hello world. So a couple of things which are different are how we are using cout instead of printf for IO. And really, we're going to what cout is. So again, to compile this, you compile this with g++ file.cpp, and this will generate a binary called Iterators, which you can run with /Iterators.
Yeah.
So again, this is just some more C++ code. The way you take, so the cin and cout, these are streams, right? They're an alternative to printf and scanf. You can think of like streams of data which you can read from or output to, and they wrap around std in and std out. You can still use printf and scanf because remember, all valid C code is still valid C++ code, but cout and cin have some really nice features. One nice thing about them is you can see here on this second last line, we are printing both an integer, which is x square, and we are printing a character and a string, \n. Whereas if you wanted to do it in C, you have to give the correct format specifier. But here I don't need to worry about the format specifier at all. C++ does everything. And the syntax for taking input is like this. It's cin sort of greater than x. You can think of it as cin providing the data into x, whereas cout is less than x times x, because the data is being pushed into cout, if that makes sense.
ये कोड करके दिखाना है क्या?
So I'll let you guys try this. I'm going to assume you guys have some kind of editor in G++ setup. So take a minute to try this out and just get the feel for this. To compile this, it's g++ file.cpp and just run /error out. Okay, sure. Cool. So here I have just a code that prints out hello world. It takes in input x and prints the q of x. And you can immediately see that just dealing with strings is a lot easier with C++ as opposed to C. And you can chain things out. So I can print multiple things at a time. So yeah, something like this. And I don't have to worry about the format specifiers. C++ will deal with everything, and that makes printing stuff out, std out really easy. Here I've used something called endl. So if you want to output a new line and you want to flush the output buffer, so I'll go into what that is later. But suppose you want to output a new line. One way to do that is what I've done here. Just you print out the character or the string \n, or you can also use something called endl. Endl also prints a new line, but there's a particular difference between the two which will be covered later on. Are there any doubts or issues so far? Cool. Now we'll be getting into sort of the main content of the meet, which is STL. One of the huge benefits of using C++ is there are various data structures and algorithms already present in the standard library for C++. They are available on your fingertips with a single line of code, which is what makes the language so powerful. In C, none of this, it handles everything. So on the right, I have some code to kind of show off how easy it is. So the first line is string S and then C and S. This will include S. So I see some of you guys are trying to get this to work. You have to include the header string. Yeah, so if you are trying this, make sure you include the header string. So in the first line, we declare a string S and we take its input, and we don't have to worry about the buffer size or any buffer overflow issues. We don't have to worry about null termination. Everything is dealt with. On the second line, we just print it out again. And the third line, we're able to access the size of the string. Whereas in C, you have to use strlen, but then strlen is also not exactly safe, and you have these huge issues. Then we have a string concatenation. So S plus equal to something that appends the other string onto the back of the first one. And to do this in C, you would have to use some other C string for library function, which is again annoying. And then we have string comparison at the last line. And here you don't have to use strcomp. S double equals S new. It's just like comparing integers. So the syntax is a lot more intuitive. It matches that of integers. And it's just frankly a lot less code.
क्या कोड करो? I don't know why you're standing there.
Okay. What is source length?
Which one, sir? What should be the time of which they compare?
Also, another pointer is the string comparison. Unlike integers, it is actually O of length, because you need to check every character once. It's O of the smaller string's length. And yeah, strings are treated exactly as arrays. They are zero-indexed arrays. You can think of them like that. But they can also be appended from and pushed, and they can even pop back the last element, which is something I'll go over. Right. So the next data structure, which is really used a lot, is something called vector. So vectors are dynamic arrays. What I mean by that is in C, you kind of have to declare a static array at the start, or as a global variable or somewhere. So in C, you would have something like int my array of size 5, or some other constant. The C style array, they cannot be resized. If I have an array of size 5, I cannot have another 6th element. I can't append to it without doing something. Whereas in C++, it gives something very similar to an array, but it's an array that can be resized dynamically. So I could have, so here in this code, so again you have to include the header file vector for this to work. In this snippet of code, on the third line in main, we declare a vector which has size n. This is quite similar to declaring an array of size n, but again, notice how n is not a constant. if I were to try to declare an array of size, a variable size, I would get a warning in C, and it might not even compile on some older versions of C. The great thing about this is that not only is it of size length n, it can also be changed. It can be resized to any size I want.
You try करना देते हैं?
So I'll let you guys try this because this is one of the most used containers. And again, notice the consistency in pattern. You have a dot size here, which will just print the size of the vector.
I think type out करता है.
Vector थोड़ा important है. How? हाँ ठीक है तू आप इसका. So any issues with vector so far? Because this is really important. So two important calls to vector are push back and pop back. So as I mentioned, these are dynamically allocated, and they can have dynamic size. So you can, from the one end of the vector, you can insert elements at the back, or you can take off elements from the back. So that's what push back and pop back corresponds to. So I'll just have another snippet of code. So here I've declared a function, which is exactly how you would in C, with some quirks to it. So actually, it's better if I show this off. So suppose if I want to remove the last element of the vector that I've taken input of, I'd have to just call pop back, and pop back would just remove the last element. And now if I take the sum, the length of the vector is reduced by 1, so the for loop would have to be from to n minus 1. And you can see what pop back does. I'll get to that. 1 second. That's a nice doubt. So here we can just see what pop back does. It just pops the last element back. Similarly, I'll be showing off what push back does. Pushback takes in an argument which is of type what the type the vector is declared as. So by the way, these angular brackets here specify that the vector will contain elements of type int, and this has to be specified at while declaring the array. It's kind of exactly like C. I could have a vector of strings here by just calling it like this, but for now let's just stick to vector of int. Yeah. So in this example, okay.
Also initialization is
Yeah, the for loop indices were wrong. In this example, we've popped back one element from the last, so 5 gets popped back, and we've pushed back 100. You might be asking, what if I want to, brace initialize or initialize a vector like I would in C? So brace initialization is still a thing. So if we don't know what that is, I'll just go over it.
इनिशियली जो डिक्लेरेशन के साथ इनिशियलाइजेशन होते हैं वो बोला
क्या?
like 100,1 it will initialize 100.
Yes, look at my screen.
The other thing.
What?
100,1 100 will initialize
Okay, I'll go to that also. So another way to initialize vectors is like this, where you can just initialize what the element should be, and it will create a vector of size 5 with 1, 2, 3, 4, 5 in it. Another way to initialize vectors is is like this, where this would initialize a vector of length n with all elements being 7. So you can again see how this would be kind of annoying to do in C. You would probably need like mem move or one of those calls. But you can just use the constructor provided for vectors. And this will create a vector of size n with all elements being 7. Okay, so any issues with vectors so far? Any doubts? So one of you guys did mention this. So how do you guys think pushback or popback works under the hood? So I know CL plus STL, you don't have to worry about any of this. But I'll tell you one thing, that these both calls are O of 1. So pushing back to a vector, it's in O of 1 time. Any idea how that would work? O of 1 on average, amortized.
In 5 minutes initially the part of maybe something like that.
Okay, but what if I initialize with 7? Then what would so what if n was 7 in this code? You're close.
Of 8 and the 8 thing would not be used.
Sure, that would work, but you can see well that's kind of memory inefficient, right? Suppose my vector was of size 1025, which is 1 above the power of 2. Then you would create a vector size 2048, creating twice as much space.
So it would be a 105, but when you push back,
Sure. So that's quite close to the answer, right? So what's internally happening is you have a chunk of memory that's allocated the first time when you initialize the vector. If you want to pop back, what will happen is you don't actually need to change the memory. You just need to maintain some internal size variable or a pointer to the end. You can just decrement that and you can say we've popped back. So pop back works in O1, it's pretty quite straightforward. Next, if I want to push back, there's a couple of cases. So let's say this was the initial chunk of memory that was allocated. After some pop back calls, the pointer is 0. Do you see how if I have any pushbacks after this, that will be O1. Right, I will just increment this pointer back. But what if there's a pushback after here? How would you resize? Exactly. The idea is to call realog and to make sure the complexity works out, it doubles in size. And I'll let you guys think about why doubling is the right number here. But yeah.
Sticker there.
It decreases the size.
How much?
By 1.
We cannot do multiple things.
You can do pop back multiple times, pop back, pop back, pop back.
Data is already stored, it gets deleted. Last time.
Yeah, it gets removed.
Iterators मैं बता रहा हूँ अच्छा तुझे अभी तू बनाना था
So do take some time to try all the things that we did discuss. If you have any doubts, let us know.
Pushback we can do multiple times. Pushback it's 100%. अच्छा खाली वो एक ही है रिजेक्ट ही करेगा
If you do have doubts, just contact any of the people present here standing. You can call them and ask them your doubts. Okay, now someone asked a doubt.
thing that happens. So if everyone's clear, we'll be moving on. Okay, so next up we'll be looking at iterators. So all of you must have seen pointers in action in C. So in C++ we have something called iterators, which basically act as pointers in containers. So we just looked at vectors, right? So if you had to iterate over a vector, one way to do it would be to initialize an iterator and then iterate over the complete vector. So there are a few iterators that we would like to look at here. So the first one being begin, which is the iterator pointing to the first element of the container. So you can imagine this as the pointer to the first element basically. And the end iterator basically points to the element which would logically come after the last element of the iterator. So if you write a loop, you can see there is an auto data type used in here. We'll go over that later. So if you start iterating from vector.begin, you can go up till before vector.end, and you can dereference as you do in C using a star iterator. So you get the value of x at that position in the vector. You can do this with other structures, other containers that we'll be covering later. So we've gone over begin and end. There is something called rbegin and rend. So rbegin basically points to the end of, so that it again points to the last element of the vector, but this time incrementing that iterator will basically move backwards in the vector. So if you started at rbegin, even though it points to the last element of the vector, incrementing doing it++ will basically move you back one element, so the second last element. And then you can go up to rend, which is logically the element that comes before the first element. So you can, so once it is not equals, you basically go up to there, and then you can again dereference it as the same.
Which one is the second first element, what is the second last element?
Begin is the first element, end is the element after the last element, and after the last element. So you can increment it till before the, to get to the last element. Rend is the last element, but it moves backwards. So basically it++ would basically shift you to the second last element.
And rbegin is the second first element.
Is the element that comes before the first element. Are there any doubts about this? Is this clear? Yeah, so this is basically how it looks like. What's so you can't basically access the elements at the vector end, at the end and the rn, because they are not elements of the. In C, this was basically give you an error. We'll be moving to AutoNet, so if you could be a little quieter, it would be nice.
Be a bit more quiet or be really nice. You can discuss, but try to do. ऑटो बस बोलते बिल एक्शन
ऑटो के नेक्स्ट The iterator has a data type, so we'll go over auto, what auto does basically. Iterator does have a data type, so for example, if this was an integer vector, it would basically be int of vector iterator. It's a huge syntax to write every time, so we'll go over how auto helps you with that.
I wouldn't be able to do that. But with this I can read in the middle. I think थोड़ी देर रुक जाते हैं
रेंज पर बता रहे हैं
बहुत बाद में बता रहे हैं
एकदम लास्ट में
Doesn't matter.
mostly because people are talking so So if you're clear with it and have implemented, we'll be moving on to the next thing. Could you please be a little quieter? So most of you might have guessed that auto is something that automatically deduces the type of variable from the thing that you're initializing to it. So in this case, 5 is an integer, so auto will directly make this is an int an integer. Same for high will be initialized as a string, and this is very helpful when it comes to iterators, because iterators have a very long drawn initialization step. So if you just replace it with auto, it becomes a much faster process. So you can try using random variables and random initializations and check out what auto assigns it to as a variable type.
Next slide here. Next slide here.
Sets of pair.
Doubts के लिए कुछ नहीं होगा.
Any doubts so far? Everybody understood the auto keyword?
Yeah, so we'll be moving on. So there is a data type called pair in C++. This is very, very helpful in, let's say you have XY coordinates, right? So you can store it in a pair. So pair in command. Now XY coordinate is not the only use case. Like maybe you want to assign a string some value. So you can have pair string comma 8 and assign, let's say hi 1, your name 2 or something like that, right? So you can declare it as my pair equal to 1 comma 2. If you put it in a tuple with like curly braces, it initializes it as a pair. And to access both the elements, you use dot first and dot second. So dot first accesses the first element of the pair and dot second accesses second element. So for example, let's say XY points again. Let's say you wanted to sort based on X points, right? So you can put X as the first one, Y as second one and sort it. So what it will do is, it will sort based on X first, and if X is same, then it will compare Y. So it will be X will have the priority. Now if you want to do with Y and X, you can just swap Y and X in the pair. So you can have pair Y comma X. Yeah, I'll show you. So for example, you are given XY points, many of them. So you want to sort them, let's say. So what you do, you want to sort them based on only X, right? So what you do, you put X as the first element, Y as the second element. Now when you compare pairs, what happens is, it will compare the first element first, right? If it's smaller, it will put that first. If it's same, then it will compare Y. So now if you want to sort one based on Y, you can put Y as the first element, X as the second element, right? Now let's say you want to have 3 elements, like you might have heard of tuples or something, but it's not recommended to use tuples in C++, but you can do this way instead. So basically PPI is basically a pair of 8 and pairing, right? So pair is also a data type which can go inside a pair. Now you can put 3 elements in the same variable, right? So this helps in maybe sorting based on 3 variables or anything you want. Let's say you guys have already learned graphs, but in graphs you might have to store the edge weight or something, right? You want to store both the edges and edge weight. So in that case you might want to store both the points and the edge weight. So it's 3, right? Guys, can you please keep yeah, we'll have time for doubts. You can ask doubts at time, please. Okay, so sorting. Have you guys learned any sorting in C? You might have learned bubble sort and stuff, right? So that's merge sort you learned in DSA, right? So you guys have learned merge sort, but in C++, C++, you don't need to write your own mode sort, your own sorts, anything. Right? You can just write sort, ARR.begin, ARR.end. Right? We cover iterators. Same way you pass the begin and end. Now it will sort the whole array for you. Right? This is guaranteed end log n, right? This is not merge sort specifically, but it uses a mix of sorts, but it gives you guaranteed end log n time. Right? You don't need to worry about the internal applications. So for arrays, right? It doesn't have array.begin, array.end. So you can directly do array and array plus 10. You would have learned this in C. Like if you do plus 10, you will do the iterator will move by plus 10 int spaces. If it was double, it would have still worked the same way. Right? If it was double, string, anything. Yeah. So for descending, can you give any ideas for how to do it descending? That also works, yes. Yeah. So for sorting array backwards, you can either put, so in CP people use a lot of tricks, right? You can do that, but let's say you're not confident of that. So there's something called reverse also. You can do reverse array and array, ARR.begin, ARR.end after sorting. Or you can maybe even put negative numbers. So people do a lot of things like this, right? Yeah. Guys, please, we can have a round of doubts, right? So you can ask doubts. If you have any doubts, you can try this out on your own. Try declaring pairs of different data types and experimenting with it. And if you have any doubts, you can ask anyone at the site.
How can you modify this? Modify this is
क्या
descending के
मैं कुछ पूछा पूछा यहाँ आंसर दिया Is everyone clear with this? Yeah. So we'll be going off. So we'll go through some data structures. We will be learning this in DSA this time. So you will learn how to implement this also in DSA. But in C++, the good thing is it's already predefined. Like I know you guys are using Python in DSA, but in C++ it's also predefined, right? So so yeah, this is a stack data structure. So stack is a first in first out. So it works as a normal stack of, let's say, books you put, right? Whenever you add something, you add it to the top of the stack, and when you remove it, you remove the topmost element, right? So dot push is basically adding to the top of the stack, and dot top returns what is at the top element, right? And dot top will basically remove the topmost element from the stack. This can be done with vectors itself, but stack is slightly faster if you want to use it, and it gives you that you are using a stack itself, right? Similarly, queue is the opposite, right? So when you add something, it goes at the back of the queue, and when the front returns the front of the queue, and dot top will remove the element at the front of the queue, right? So the first element which was added gets removed. Deque you can do both ways. So you can add elements at the back, you can add elements at the front, you can remove and add elements from the back and front. So the functions are very readable and they do exactly what they mean. So
Everybody is clear with this? Again, whatever deque does cannot be done with vectors, right? And whatever q does. Stack can be kind of done with vectors using pushback and drawback, but deque and q cannot be done using pushback. Deque cannot be done using vectors. Okay, so going on, there is things called sets and multisets. So you guys have discussed sets in maybe discussed structures or something. So can someone say what it does? Collection of
It's a collection of similar kinds of
it's a collection of similar types of elements, but what could be unique about sets? Like, yes. So in set, what happens is if you add an element of a type, there's only one copy of that. In multiset, you can have multiple copies. Right? So I will quote this little bit. The syntax.
set, multiset. What exactly does it show? Insert वगैरह?
So you will demonstrate a few basic set and multiset operations.
ऑटो बता रखे हैं रेंज फॉलोअर्स.
So you can add elements into the set using dot insert function. Right? Dot insert will add an element to the function. You can also erase using dot erase. But while erasing, make sure that that element exists already in the set, or else it will give a set fault or it will give error. Right? So the element must exist.
ये दिखा देता हूँ. ये दिखा देता हूँ. बोल एक्सपेक्टेड आउटपुट. एक्सपेक्टेड.
Yeah, so here is basically we are adding elements to the set, 5 elements. So what do you think will be the elements in the set right now?
एक्सपेक्टेड आउटपुट.
Anywhere else?
1, 2, 3 only.
Yeah. So it will output 1, 2, 3 since repetitions are not counted, right? Yeah, so you can change it to multiset and try this out. Yeah, so in a multiset what happened was it gave the whole element, right? So everything was good. Now, while in this is important, so it erase of multiset. If you erase one element, it will erase all elements of that type. So in this case, if you did erase 3, you would have erased both the trees, right? So how do you not do this? You do multiset dot erase, multiset dot find. So you pass it, okay, dot find basically returns the iterator to the element, right? Iterator is the iterator. Now if you erase the iterator, it will erase only one element. If you are feeling that this is slightly hard to follow, remember or something, there is CPT reference which you will be following. Google it. This is how you get used to all these data structures. You won't get this in your first attempt, right? So use them, only then you are going to learn all this. Yeah, find returns. If that element exists, it will return the pointer to that element, or else it will return myset.end. It will return the set.end, right? If the element does not exist. It returns the dot end iterator. Yes, it's garbage. So, but you can compare and say if it is equal to dot end, that it does not exist. So there are a lot of other functions. These are the main ones.
हाँ लाइट. अभी बता लॉगिन
Okay.
कुछ नहीं बताया.
Yeah.
और
So what do you think is the use of
having sets over vectors.
Often.
Often. Why do you think so? You're saying use for vector over set, right? What is the use of set over vector? When would you use a set? When would you use a vector? What about sorting mixed? What is the use of sorting? Okay, the answer I got is if you want a sorted list, use set or else use vectors. Like if you want to preserve the order you want, use vectors. But okay, let's say I don't care about order and you're using set, right? What property of it being sorted is good? What is it? Yes. How do you find So basically, in a set, let's say you want to find the element if it exists, if it does not exist. This can be done using, I'm pretty sure you all know this, right? Since it's sorted already, you can do this in login type. You can find the element, erase it, add it, everything in login type, right? And it always maintains sorted. So you can find max, min, everything quickly. Let's say your array is not predefined, you keep getting the inputs, right? And after getting the input, you want to, let's say, output max or min, you want to erase elements. In this case, you can just keep a set and add a new element from it, right? And all this happens in login type. This is the main use of set, right? I think somebody said you can find the median element also. In set, you cannot find the median element directly in C++, right? Because if you do size by 2 also, then you cannot find the middle, like let's say you have 10 element, you can't find the fifth iterator directly. So iterator operations will go one by one, right? So that won't be login, that will be off, like 5 off n. So the benefits of using this is the sorting in the binary search, but I just wanted to, I think there's a couple of terms. This is not implemented as an array. So the elements are not stored in contiguous memory location. So I can't just access the fifth element. They are actually stored as some kind of tree structure, and you'll probably be implementing this in your data structure source, as with most of the other data view stack. But the power of is you have this identification still in online. This is what we really wanted to motivate for this. Yeah, again, you are not going to learn all this in this one session. We will be sharing our problem set also with you, and you have to keep solving problems using this to get a hang of it, right? To get a hang of all the functions. Feel free to Google. We will give you references also. So yeah. So again, dot lower bound. This is how. Okay, so dot lower bound. What do you think dot lower bound does? Smallest element larger than. So what it does is when you do lower bound, it returns the smallest. Let's say you do lower bound of x. It will return a pointer or iterator to the smallest element greater than it, right? So you can find the next greater than equal to it, and our bound returns smallest element greater than it. Greater than equal to. Yes, upper bound is greater. Yes. And let's say you have a set of 1 to 55 and you do upper bound of 5. What do you think will happen? Anybody? I need upper bound of 5. 5 exists? Yes. No, a lower bound is greater than equal to upper bound is greater than 5.
It will 6 or more whatever exists.
I'm saying only 1 to 5 exists. So it will return the end iterator. So this is where all you might say what is the use of end iterator, right? Like you cannot use this at all. Like you cannot access it. What's the point of it?
Add 6. 1, 2, 3, 4, 5 input is there. What will be the output? Right.
dot lower bound. So it will give you an iterator to the end operator. So now you have to make sure in your check you have to have a if condition that ITR not equal to set dot end.
Then example, explain the
Yeah, we will code it up, sir. Okay, I have a question. Let's say you want to find the iterator to the element just smaller than the number you, let's say just smaller than x. What would you do?
R dot.
You find the lower and then move back.
Yes. So you, iterators also do plus plus minus minus, right? So you can do lower bound, then do ITR minus minus.
Oh.
Yes. So this. One more question. Let's say you have a multiset of 1 1 1, 2 2 2, 3 3 3, and now you do dot low. Okay, let's say array. Upper bound, lower bound works in sorted vectors also, sorted array, sorted vectors. But make sure it's sorted, or else it will give you undefined behavior. It might give you wrong answers, right? So let's say in your array you have 1 1, 2 3 3, right? Now if you do lower bound of 3, what do you think it will return? Like these are the indices, right? These are the indices of the vector. So what do you think it will return? It will return a pointer, right? Yeah, that. Okay, yeah. So it will return the pointer to the first 3 you are searching for, right? It will search, and if you do let's say upper bound of 2, then also it will return to this one, right? It will return to the first element. So when you do minus minus, you are guaranteed to go to the just smaller element. If
Repetition also.
what?
Repetition also means that 3 is there.
Yes.
It will be the smallest first occurrence.
Yes, first occurrence it will come. Yeah, so the implementation of how to use lower bound, upper bound. Yeah, so you can see that he has done ITR equal to myset.end, cout, and iterator return. So you have to handle this when you are doing lower bound and upper bound. Okay, so the point of the end iterator is the lower bound of a number in the set need not always exist. For example, if this is my set 1 2 4 7, the lower bound of 8 doesn't exist. There's no element in this set which is just greater than equal to 8. So the point of the end iterator is it's kind of like my it's like the no garbage can of the city type of thing where you can compare it with the end iterator, and if I received it, so it's kind of contract. So you say if you get the end iterator, it means that the lower bound is alpha.
Upper bound of 7 is.
The upper bound of 7 also does not exist in this. It will be the end iterator. Yes.
If something does not exist, it becomes an entity.
Yes. Pretty much. Yes. Pretty much. And make sure you handle this iterator in the condition like we are done.
Multisets similar.
Yes.
If it does not exist,
Yes.
some garbage value.
Yes, even in vectors, even in everything. Like C++ is very uniform across the things. Yeah, so I will open up for doubts for finance. This is important. This is the main thing you are using C++. Then maybe you can implement tax view or something in C. But this is my these are very hard to implement. So this is where C++ is very important that data is available. So if you have any doubts, I'm open. Also, I do recommend trying this out on your own, like implementing this on your own right now. To get maybe if these failure issues you can resolve.
वेट करना है क्या?
Yeah, also if you have noticed, to access the element of iterator, you have to use star idea. You can just like pointers.
किस गिरा गया?
So just like pointers, you have to access star idea. And if you do star idea on a dot head, it will give you a value. So handle that using this method. It's not continuous memory. It has a like forward and stuff. You'll be familiar. You'll be going over how all of this works in your you learn this much. You have point you need to worry about it. Yeah. It's fast and it works. And you cannot keep sorting after every push continuous step, right? So you start at the side. I'm assuming all the output here. Yeah, so we'll go that. Yeah, so one more lesson. Can you guess what math is? Like, obviously, there are this one is so you can map two data types basically. So in this example we are given int and string, right? It can be anything, it can be int, double, anything you want. And so you can access MP1 equal to just like that, but it does not have a size already, right? Now you can see that you can add random elements. You can have MP1, MP10, etc. And all of these will be, let's say you have not added MP2, right? So if you access MP2 and it's a type of string, it will give you a 0. If it's a string, it will give you an empty string, right? For now, this is for auto P and P. That's it. What do you think they will do? Yes. So what do you think P dot first is P dot second? So P dot first is the first element of the letter. P dot second is the second element, right? And now you can print that in that fashion. Also, now let's say what you do, you just access MP2, right? You said if MP2 equals something, do something. Right? This is not right? So let's say you access in this case before the for loop, before the for loop you said if MP2 equal to print something, right? But MP2 did not exist, so it not print anything. But now when you do the for
Keep that now.
What do you want me to do? I didn't hear.
Go back.
Okay.
Just access. Map.
Map वही बना रहा था.
Map. Access that before this thing.
so we will put it after. What do you think will happen? So what I will is MP1 equal to string 1, MP7 equal to string 7. Now I did if MP2 equal to let's say 2, print 2 exists, right? Then I did for auto P print P dot first, P dot second. So what do you think it will print?
You can print 1, 1 and 7.
I have answer saying 1, 1, 7, 7. Any other answers? You're saying 1, 1, 7, 7, right?
My laptop is out there.
So it also printed 2 because you access 2, right? So remember you didn't set it to anything. When you access MP2, it set it to a null string, like empty string. So how do you avoid this? So you do if empty to the count. Right? Count returns if it only if it exists, it will go there. We'll show how to do it.
मेरा लैपटॉप अगर चार्ज कर
And
एंड ठीक है ओके ठीक है लाइट
so in this case, when you draw count to, it does not print it. So it's only 1 1 7 7. Count returns if that